Let's discuss Unit 3 Programming Languages and Computer Graphics questions. Consider the following piece of C programming code. Int x is equal to 128, y is equal to 110. Inside the do while we have if conditional along with else part. Then we have a printf statement. This printf is actually printing the value of x. Actually, whenever you have a do while statement, irrespective of any condition that appears in the while, it will execute for one time, and after execution it will check the condition at the end of the loop. So once the condition is true, it will again go and execute. If the condition is false, then it will exit out of the loop. Let's see what is inside the loop. If x greater than y, x is equal to x minus y. If x is not greater than y, then the else part will be working. Y is equal to y minus x. And see the condition in the while here, it is x not equal to y. Whenever we have different values for x and y, till then the loop will be executing. But when x value and y value becomes equal, you have to exit out of the loop. So the exit condition here, it will be x is equal to y. Now we will start the execution with the first value, x is equal to 128 and y is equal to 110. So initially it will go to the if condition. If 128 is greater than 110, yes, it is true. If it is going to be true, which part will be executing? This part. So x is equal to 128, which is x value, minus 110, which is y value. 128 minus 110 will give you 18. Now the new x value will be 18 and y value will be retained as it is. X is not equal to y. So it will once again check for if x greater than y. Here 18 is not greater than 110. So this condition is false. Then automatically else part will be executing here. Y is equal to y minus x. Y is equal to 110 minus 18, which is equal to 92. Again we have x is equal to 18 and y is equal to 92. So the loop will again be executing. 18 is not equal to 92. That's why we are entering into the loop once again. Still 18 is less than 92. So based on the false condition, y is equal to y minus x will be getting executed. 92 minus 18 will give you 74. Again we have x is equal to 18 and now y will be equal to 74. 74 is still greater, so the false part will be executing. Else y is equal to y minus x will this time give 56 and x is equal to 18, y is equal to 56. This will end up with executing the else part once again. 56 minus 18 will give you 38. Now x is equal to 18 and y is equal to 38. 18 greater than 38, it is false. So the else part will be executing. Y is equal to 38 minus 18, which is equal to 20. Now we have x is equal to 18 and y is equal to 20. Still 18 is less than 20. So this false part will be executing. Y is equal to y minus x. Now y is equal to 2. So we have x is equal to 18 and y is equal to 2. Still they are not equal. So now we are entering this if part. 18 greater than 2. Yes, it is true. So 18 minus 2 will give you 16. Now x is equal to 16 and y is equal to 2. So again 16 greater than 2. Yes. So 16 minus 2 is equal to 14. So wherever you have x, there x minus y will be there. Wherever you have y, y minus x will be applied there. So this evaluation has to be taken whenever x is greater. This evaluation has to be taken whenever y is greater. So now we have x is equal to 14, y is equal to 2. So 14 is greater than 2, which is true. 14 minus 2 will give you 12. X is equal to 12, y is equal to 2. 12 is greater than 2. So 12 minus 2 is equal to 10. X is equal to 10, y is equal to 2. 10 is greater than 2. 10 minus 2 is equal to 8. 8 and 2 now. 8 is greater than 2. So 8 minus 2 is 6. 6 is greater than 2. 6 minus 2 is 4. 4 is greater than 2. 4 minus 2 will give you 2. Now what is the value of x? X is equal to 2. And what was the value of y? Y is equal to 2. Now it will enter here and the condition here will get failed, so it will exit out of the loop. So 2 is equal to 2, which means x is equal to y. This condition becomes false. So now printf will get executed. So we are printing an integer, that is why we are using %d, and it is printing the value of x. What is x value here? It is 2. So option number 2, x is equal to 2 will be the right answer. You need not go through all these stages also. Once you know it starts decrementing by 2, ultimately 16 minus 2, 14 minus 2, 12 minus 2, 10 minus 2, 8 minus 2, 6 minus 2, 4 minus 2 will bring x to 2. Here itself you can guess the answer of x to be 2 just by thinking it in your mind itself. So once you get an idea about x value in these two stages, you can stop it and then mark the answer, because you have crossed 92, you have crossed 74, and you have crossed 18 also. X was 128 initially, that is not there in the option. X never became 92 and 74. Y values were 92 and 74, so you could have ruled out 3 and 4 already. After 128, x is directly getting the value of 18, but after 18, when you are coming to this stage, it is changing to 16, which says 18 is also not the answer. From here, when you rule out 1, 3 and 4, you can mark 2 to be the right answer. So why am I telling you to process based on this particular statement or based on these particular values is, in the point of examination, you cannot keep executing every evaluation part and then checking due to time constraint. So this question can save some time when you stop here, and that time could be put for another question. That's what I'm saying. You can allocate the time for some complicated questions rather than spending it for such simple questions. Next question. Which of the following technique is used for clipping? This is from computer graphics. Based on the name, I think you can mark option 3 to be the right answer, because you could have come across this name in some previous year question papers. Any procedure that eliminates those portions of a picture that are either inside or outside a specified region of space is referred to as clipping algorithm or simply clipping. When you take a particular image that is going here and there, when you say I want to view only this particular part in my device, for that purpose only computer graphics will use the term clipping. You are clipping the view of the particular scene to a particular area. So they say eliminating the portions of some picture that is inside or outside a specified region of space. So what are the different techniques of clipping that is available? Point clipping. Then we have line clipping. In line clipping, we have 3 algorithms in the reference book: Cohen-Sutherland, Liang-Barsky, Nicole algorithms. What is Cohen-Sutherland or Sutherland-Cohen? Both are actually same. Divides space into regions and uses binary codes to classify endpoints. Liang-Barsky uses parametric equations for faster computation. Nicole is optimized for lines that are mostly visible. So from this we can mark option number 3, Sutherland-Cohen, as the right answer, because it's a line clipping technique. So you have to know which clipping has this particular algorithm. That's why I am listing it under the clipping technique. Then we have fill area clipping, that is polygon clipping we will say. Sutherland-Hodgman algorithm, and we'll have Wheeler-Atherton algorithm. Sutherland-Hodgman will clip polygon edges one at a time against each boundary, and Wheeler-Atherton algorithm is better for concave polygons and complex clipping windows. Actually, in unit outline series, I would have discussed few of these algorithms, at least for telling you what these algorithms will do. Then the final 2 clipping techniques will be curve clipping and text clipping. Now we know this is the right option, Sutherland-Cohen. But what are these wrong options are for? Stack based seed fill algorithm is a region filling technique used to fill enclosed areas in raster graphics. So clipping is actually eliminating, but here seed fill is actually region filling technique. That's why they have stopped with seed itself. So if they know it's a fill algorithm, from the name itself you can say it is not for clipping. So in order to give confusion only, they have stopped the name. Then we have scan line seed fill algorithm. This is another area filling method, but here this works line by line is what they say. Scan line means row by row it will go. So 1 and 2 are not there. What about inverse scaling? This is a transformation technique used to reverse the effect of scaling. Scaling means you are just magnifying the image by 2x or 3x. Inverse scaling is just reversing the scaling effect. So it has nothing to do with clipping or filling here. So inverse scaling can also be ruled out. Whenever you work with such questions, try to have more information about the wrong options so that you will have some additional learning, and that will definitely help you in some other question paper. Next question. What will be the output of the following C programming code? We have int I comma j. We have two loops here. It's nested for loop. For I is equal to 1, I less than 5, I is equal to I plus 2. For j is equal to 1, j less than I, j is equal to j plus 2, and we are printing j. So let's take I value, j value. We will check j less than I, the inner for loop first, and based on that we will see whether the statement is printing j or not. Then we are incrementing the inner loop here. So this is completely the for loop of j. And here this is the outer loop that will increment I. Now we will start with I is equal to 1. So once I is equal to 1, you have to start from j is equal to 1. So it is 1 here. 1 is less than 1 is false. So when it is false, it will exit out of the loop and nothing will be printed and nothing will be incremented to. Now we have to increment the value of I. I is equal to I plus 2. I plus 2 is 1 plus 2, which is equal to 3. So now the new value of I is 3. Once again we have to start from j is equal to 1. Now check the condition. J less than I. 1 is less than 3. Yes, it is true. When it is true, what value are you printing here? You are printing j. So j is 1. Now after printing you have to increment j, which is j is equal to j plus 2. J plus 2 means 1 plus 2, which is equal to 3. Now you have the value of 3. This is the inner for loop is getting executed. So you have to increment j and go with the same I. Now the new j value will be 3. Now check the condition again. J less than I. 3 is less than 3 is false. So we are not printing anything new. I am not copying this value for this particular condition. I am checking whether it is printing j or not. It is not printing. So you are exiting out of the loop. So here we are exiting and here also we are exiting. Now we are incrementing the value of I by 2. So 3 plus 2 will give you 5. Now we have I is equal to 5. What is the for loop stating here? I is less than 5. So here it will exit out of the outer loop because 5 is less than 5 is actually false. We have only 1 that is printed. So we will go with option number 1 as the right answer. Next question. What would be the equivalent pointer expression for referring the array element? Array of M, N, O. This question has already been asked in one of the previous year question paper. Let's take an array with dimensions x, y and z. It's a 3-dimensional array. AR of M gives a pointer to the 2D array, which is AR of M, Y, Z. It means this is a pointer to this particular array. In what way we can represent it? AR plus M moves M blocks of this particular 2D array. When you have the pointer symbol here, this gives the 2D array at index M. So I am just interpreting how AR plus M will work and pointer of AR plus M will work. Next we will get into the second dimension, AR of M and then N. This gives a pointer to the 1D array here. So M index is here, N index is here, we have the Z dimension array here. AR plus M is actually the index m. So we are taking this as it is. This part is taken plus n, like plus m. Plus n will move n blocks of Z array. But here when you use pointer again with this particular reference, this will give the one dimensional array at mn. Then we have AR of MNO, 3 indices are here, gives the actual integer value at that location. So how will we refer this one? So in order to get the exact integer value, what you have to do? We have to have plus O. Along with it, you are adding the pointer symbol here. Only when star of pointer is used, the value will be taken. When you use only the pointer, that location will alone be taken. So this will give the value. Which of the option is actually matching to this one? Star of AR plus M is available here. Then star of the M index with N is available here. Then star of Mn with O is available here. Option number 4 will be the right answer. Now we will see why 1, 2 and 3 are wrong. This is actually adding m and n together before indexing, which is not correct for separate dimensions. What they have done here is they have taken this particular part separately and they are adding m plus n. This plus m is a reference to the 2D array YZ here as we saw. But giving m plus n is not correct when you are using m dimension and n dimension separately. So that's why 1 is wrong. What about 2? This particular part is equivalent to AR of 0m. That is row m of first 2D array. This is first 2D array and this is row m. And when you have another index, that will be column. So here this is the first 2D array. Every array will have index 0, 1. So when you have 0 of a 2D array, this is the first 2D array. This is the meaning of star AR plus M. Star AR plus M with the braces together is AR of M, where entire 2D array at index M is referenced here. So this is the meaning that is given here. When the parenthesis is used along with plus m, that will give this meaning. When the indirection operator is used with the array and you are then adding plus m, that is equivalent to this particular row of first 2D array, they say. The meaning is different. So second option will also not be equivalent. What about third option? This one is right and this one is right. They have just added plus O. What will this actually do without this particular pointer symbol? It's a pointer to this particular location, not the actual value. Take a particular array, M, N, O is referring to a number called 9. This particular third option will point to the particular value, but it is not the actual value. Only when you have the star symbol along with the pointer, it will give you the value which is present here, that is equal to 9 that we have taken for an example. So since it's a pointer and not the actual value, we are ruling out even option 3. So understand, they are asking equivalent pointer expression for referring the array element. So they are saying the element has to be accessed. It means they want the value at that location. If the location is getting pointed, then we are using option 3. Next question. What will be the output of the following C programming code? They have declared a pointer star I here. A is equal to 12, B is equal to 2, and then they have declared C. C is equal to, inside the parenthesis, they have given 4 kinds of expressions separated by comma. Then I is equal to ampersand of C, which is actually referring to the location of C, the address of C. Star I will give you the C value. Decrement part will actually decrement the value by 1. The comma operator evaluates each expression from left to right, but only the result of the last expression is assigned to C. It means all the 4 expressions will be evaluated and only this expression's value will be stored in C. So let's take the first expression. A is equal to A plus B. It means A is 12, B is 2. 12 plus 2 will give you 14. Now the value of A is 14 and B is 2. Now we will go for the second expression. B is equal to A by B. What is A now? It is 14. What is B? It is 2. 14 divided by 2 is 7. So now A is equal to 14 and B is equal to 7. Now we will go for the third expression. A is equal to A into B. Now A is 14 and B is 7. 14 into 7 will give you 98. This is A. So A is 98 and B is still 7. Now the final expression, B is equal to A minus B. So here A is 98 and minus B value is 7. 98 minus 7 is 91. The B value is updated to 91 while the A value is same as 98. Now this is the last expression. Whatever value becomes the result of the last expression, that is assigned to C. The result of the last expression is 91 and this value will be assigned to C. You can ask me, we can actually compute B is equal to A minus B and put it in C. Just compute A minus B. 12 minus 2 will give you 10 and you are going to put it in C. That is not the case here. They want you to evaluate these 3 expressions, update the value of A and B internally and then use the updated value in this particular expression and then finally store the result in C. Now what is I is equal to ampersand C? I is pointing to C now, which is 91. So this is holding 91. Decrement operator will decrement C before printing. So here if I say minus of minus I is equal to I minus 1. When it is minus of minus C, it is C is equal to C minus 1. So in the same way, minus of minus star I. This star I is having the value of 91. Since we use decrement operator here, it is reducing 1 from 91 and the final value here will be 90. That will be printed in the printf statement. Option number 2, 90 will be the right answer. Star I will have the value of 91. Decrement operator will decrement it by 1 and then bring to 90 for the whole expression. This 90 is an integer because star I is an integer here. So we are using percentage D to print it. I hope it is clear for you. Next question. Consider the operators used in C programming. We have been given 5 operators. Choose among the following the correct order of precedence of the operators given above. We have to start from the higher precedence and go to the lower precedence. So let's take the precedence of operator along with the associativity here. So now we will just see the symbol. Double ampersand is for logical and. This is A. Then we have plus equal to, this is actually assignment. It is present here. So this is B. We have 2 greater than symbol which is actually shift operation. So this will be shift which is C. Then we have greater than or equal to, this is relational operator. So we have D. Then we have the conditional, the ternary operator, question mark and colon. This is available here. So this will be E. This is arranged from higher precedence to lower precedence. So the order will be C, D, A, E, B. Option number 3 will be the right answer. Next question. Consider the following statements for XML, extensible markup language. The number of tags decreases and users can define their own tags. Actually, this part is definitely true. We can define our own tags. It's not like HTML. HTML has a specific set of tags. We have to use that only. But XML is not so. It is used for presentation. It is case sensitive. It is dynamic. So let's see. XML is strictly case sensitive. The tag capital N in name and small n in name are treated as completely different tags. In HTML, when you write it as bold or bold, both are actually same. When you say IMG or IMG, both are same, but in XML, they say even a single letter that is given in caps will give difference. So it is strictly case sensitive. C is definitely true. The option that does not include C will be removed. What about dynamic? XML is considered dynamic because it's used for transporting and storing data which can then be used to generate dynamic content in web application. Generally, XML is not used for showing something. Displaying purpose is actually done by HTML. Using HTML, you can display any kind of information. XML is not for that purpose. When you take this particular point, you can easily say that B is false and D is definitely true. Coming to A, users can define their own tags. This is fine. But actually, there is no rule that XML will reduce the number of tags. Based on particular application, the tags might get increased or decreased due to this particular part. This statement is not completely true. But since we are ruling out options that involve B, we have only option 3 left out with ACD. XML is primarily designed to transport and store data, and for presentation we are using HTML. They are including A in the official answer key because of this particular statement. This is perfectly fine. But this depends on the project or this depends on the application. Since they say it is for transporting and storing data, when we reduce the number of tags, the number of information that is being transported or stored will be less. Based on that aspect, some articles might support this statement, but in general doesn't by default reduce the number of tags because you are actually creating the tags. So just keeping this particular point in mind, we can mark A to be true. I am marking option number 3 ACD only as the right answer. Next question, only legal pointer operations. Pointer along with a number. When it undergoes addition, it will end up giving a pointer. A is actually adding an offset. Offset means a number to the pointer. This will result in a pointer. This is perfectly true. Subtracting an offset from a pointer will result in a pointer again and not a number. So this particular part is false. It will again result in a pointer only. So from this we can rule out B. Once you know B is wrong, you have the answer. Next, pointer plus pointer will end up with pointer. Adding 2 pointers is not allowed. C is also not there. Pointer minus pointer ends up in a pointer. Subtracting 2 pointers gives a number, not a pointer. We have a pointer here and a pointer here. Subtracting them will say how many locations or places are in between them. It is not about a pointer again. So this is also wrong. So now we have pointer minus pointer, that gives a number. This gives the number of elements between 2 pointers. If I have 4 numbers between these 2 pointers, then the difference will be 4 here. So subtraction is allowed, but that will give the result as number of elements between those 2 pointers and not a pointer. So based on D and E, we can say E is right and D is wrong. So from this we can mark option number 4 AE only as the right answer. You should get a list of valid or legal pointer operations that are allowed, and you have to get invalid pointer operations. Have a learning, have a comparison so that it will be helpful for you in some other question paper. Next question, match list 1 with list 2. Now we will go with overloading and overriding. Both are terms of polymorphism. When we say overload, it means this will occur at compile time. When we say it is override, that will occur during runtime. Since we know overloading is directly denoting polymorphism, we can mark A23. Overloading supports compile time polymorphism and overriding supports runtime polymorphism. C is mapping to 4. So we have A3, C4. What about early binding and late binding? This will also carry the same idea. When something happens during compile time, the execution will be faster. When something happens at runtime, only during the runtime you are going to substitute a value or do a function call. The execution will take some more time. I mean, it will be slower. So now we will see, since function call is resolved during runtime, the execution is slow. So the slower execution happens because of resolving in runtime. And since the function call is resolved during compilation time, the execution is much faster. Early binding is when it happens during compile time. So we can say B is mapping to 2. And late binding is related to runtime because it's about slow execution, and D will be mapping to 1. Why am I writing this here separately? Because B2 D1 is available here and A3 C4 is available here, which means this question is dropped in the official answer key because no option is actually having A3 C4 B2 D1 together. All the options are wrong. Next question, match list 1 with list 2. This is from computer graphics. Oblique projection, cavalier projection, cabinet projection, orthographic projection. First we will see about oblique and orthographic projection, and regarding B and C, they are actually types of oblique projection. So first we will cover A and D. This is orthogonal or orthographic projection and this is oblique projection. Here we have a term called foreshortened, no foreshortening. In projection, generally we don't have this foreshortening and all. Foreshortening means getting shorter than the usual one. So we don't have that term. So we will see about 3 and 4 now. When the direction of projection is perpendicular to the plane of projection. Perpendicular means it will be in this form. Parallel means it will be in this form. So perpendicular means at 90-degree angle you can take. So which projection is in perpendicular form? Orthogonal. That is, orthographic projection is in perpendicular form. So D will be mapping to 3. D3 is available only in one option. What about oblique projection? When the angle between projectors and the plane of projection is not equal to 90 degree. When it is 90 degree, it is perpendicular. If it is not 90 degree, then that is oblique projection. So that's what you can see in the diagram here. I am not getting into the discussion of the diagram, but just to show you how it looks. So A will be mapping to 4. A4 is available here. Actually it is available in both the places, but here D is wrong. So we can rule out 4, and from D we can rule out 1 and 3 also. From D itself we can rule out 1, 3 and 4 options. We can say option number 2 will be the right answer. Now we have to see how B is 2 and C is 1. This is general oblique projection. They say it is just scaled. It is not full or half. When it is full scale, you can see this particular image. When it is half scale, you can see this particular image. When it is half scale, it is cabinet. When it is full scale, it is cavalier. So just take this to be scale. The original one. When it is full scale, it is just stretched. When it is half scale, it is just shortened. So this foreshortened term is actually denoting this shortening part. Now let's see the first statement in list 2. When the direction of projection is so chosen that the lines perpendicular to the plane of projection are foreshortened. Foreshortened means they are not stretched or elongated, they are made small. So this foreshortening is the term that is used for half scale. So which projection it is talking about? It is talking about cabinet projection. C will be mapping to 1. C1 is available here. Then what about full scale? When the direction of projection is so chosen that there is No foreshortening of lines perpendicular to the plane of projection. It is taken as full scale. You are not shortening it. See, this is the complete scale you can take, and this is half scale. This is the general oblique projection. You don't consider this as of now. Only compare these two diagrams. I am just telling you how it differs from oblique projection. This is just to give an overall idea. This no foreshortening is the clue for full scale here. So B will be mapping to 2. B2 is also here. Orthogonal is talking about the direction of projection is perpendicular to the plane of projection. You will know that if the plane of projection is not equal to 90 degree, that will fall under oblique. Under oblique, you have two types, cavalier and cabinet. When it is a full scale view, you go for cavalier projection. When it is half scale, that is when the lines are foreshortened, that comes under cabinet projection. So have an idea about all the projections so that it can help you in some other question paper. With this, we are completing Unit 3 questions.